All right. Oops, forgot the microphone. Let's get this thing hooked up. There we go. All right. Let's see. So we did about half of this lesson yesterday, so let's try to continue. This time we're going to talk about two different triangles. And let's see. There's one triangle. Okay. So let's just draw just any old triangle. It doesn't matter how we draw it. Just draw it like this and like this. Okay. And I'm going to copy and paste it. Put that over here. And I'm going to call this one ABC. And I'm going to call this one XYZ. Actually, it doesn't matter. I'll just go like this, XYZ. Okay? All right, here's what the theorem says. It says if two angles of one triangle are congruent or equal to two angles of another triangle. So let's mark that. Let's make that a different color. So here's what it says. So if you have two angles from this triangle equaling two angles from this triangle. So watch. If I have angle A equals angle X, okay, that's one angle from one equaling one angle from another. But what does the theorem say? If how many? What did I just say? If two angles, right, from one equal two angles of another. It doesn't really matter which ones we mark. Let's mark these right here. This has a little bit to do with what we talked about yesterday as far as all the angles adding up to something. What do all the angles add up to be? How many degrees? 180 degrees. Very good, okay? So if you know that, you probably know what the rest of this is. So if these two angles were if you add up these two angles and it equals the same thing as you add up these two angles, what's going to be true about the third angles, do you think? Do you think this one's going to be bigger than this one? Think this one's going to be smaller than this? Or do you think they're going to be equal to each other? Okay, they're going to be absolutely equal to each other. For instance, let's just put some numbers in. Now, we know they have to add up to 180, but let's say, I don't know, this looks like a pretty big angle, so let's say that's 70 degrees. And I don't know, let's say that's 30 degrees, okay? I'm just making up numbers, all right? So again, that's 70 and that's 30 right there. So check this out. If this is 70 and that's 30, what do they add up to be? 100. So what's this angle right here have to be then? This has to be 80. Agreed? So what does this angle have to be? It's got to be 80 as well, because I'm taking the same two numbers away from 180, aren't I? I'm taking 70 and 30 away from 180. I'm taking this 70 and 30 away from 180. So what must be true about the third angle then? They've got to be equal to each other, okay? Even if I didn't tell you that C and Z were equal to each other, then you should still be able to figure that out. That's as simple as that. That's not too hard, is it? I did a little bit of proof, but this really isn't a proof, but it's just kind of a demonstration that it works. So I think I'll just leave it at that. So let's go to the next thing. Everybody understand what that means? So if I have an angle or a triangle here, and if I know if two of these angles equals two of these angles over here, I know the third angles have to be equal to each other. That's really all it says. Okay? Let's do something else. Let's go back to white. All right, so I'm going to draw a triangle. Yeah, makes it look like that. And then I throw something else in here. Let's see. Yeah, I'm just going to put it about right there. So I actually have three triangles, right? I got the whole big one. I got this little one right here, and I got this little one right here. Everybody see that? All right. So really, I've got these two triangles. So remember what we just talked about. If two angles from one triangle equals two angles of another triangle, then what's true about the third angles? They're going to be equal as well. Got it? Okay, keep that in mind. So they give us a few things. Let's change colors to this. They tell us that this angle right here is 36 degrees. They tell us this one down here is 60 degrees. They tell us this one is 45 degrees, right? And then they ask you to find these three angles. They ask you to find angle 1, they ask you to find angle 2, and they ask you to find angle 3. Everybody with me? All right. Let's move this over just a little bit, give myself some room to write. Let's just push this over there. All right, now I got this space over here. I can do some writing. So, I'll do white. It's easier to see in white, I guess. Okay. So let's do angle 1 first. All right. Everybody should be able to find angle 1 because of what we talked about yesterday, and we kind of mentioned it a little bit today. So look, I've got this is 36. I've got this is what? 60. So what do I do to find angle 1? It's actually pretty basic. What is it? I add what? 36 and 60. Okay, let's do that. I add 36 plus 60. What does that give me? 96. And these are all in degrees, okay? Is angle 1 96 degrees, though? No. Okay, this doesn't just equal what these two add up to be. So how do I find angle 1? I added these two up. So angle 1, how do I find that? Take it away from what? 180, exactly right. So I added those up, and now I just take it away from 180. And that gives me, what's that? 84? Okay. So angle 1 equals 84 degrees. Let's put it in here. Tell you what, I'll get rid of the 1 and just put 84. Because that's going to help us find the other two angles, okay? Everybody with me? Now, angle 2, there's only one step to angle 2. And I'm going to show you something after we find that. It's kind of interesting because we're going to do a theorem in a bit after we finish this one that's going to mention this, okay? So this, I think they put this here for a reason because of what they're going to do next, all right? So just watch. So look at this big angle from there to there. How many degrees is that, the whole big angle? It's a straight line. We talked about this yesterday, I believe, didn't we? A straight line is equal to how many degrees? 180 degrees, isn't it? Okay, so if the whole angle, that whole big angle is a straight line and it's 180 degrees, how do I find angle 2 if I know that's 84? Subtract it from 180. So 180 minus what? 84, and that gives us, what's that? 39, is that right? No, I'm sorry. It gives us 96 again, right? Yes? Yeah, it gives us 96. I was looking at something else, looking at angle 3. So that's 96 degrees right there. Let's take, before we go, so we got two of them, right? We got angle 1 and we got angle 2. All right, that was pretty easy. Didn't even have to know anything about triangles, did you? All you had to know was if you have a straight line, that's 180 degrees. And these two angles make that 180 degrees, so you just take the 84 away from 180. Agreed? But I want you, look at that 96. We came up with 96 a little earlier, didn't we? What did we do to get 96? We added what? The 36 and the 60, exactly right, okay? Now, what I want you to look at is, I'm not going to tell you the whole theorem right now, but you see angle 2, right? We got it by going 180 minus 84, but there's another way you could have gotten it. What's another way you could have got 96? What did we just say? Add up 36 and 60. Do you see that? All right. We're going to talk about that in a minute, okay? But I just wanted to point that out to you because it's kind of interesting. That if I just took 36 and 60, that angle 2 right here is actually equal to those two added up, all right? And that's going to help us out. I don't know, some people would rather add up 36 and 60 than take 84 away from 180. Agreed? Because look what you had to do. In order to get angle 2, you had to add those up and you had to subtract it from 180 to get this. Then you had to subtract 84 from 180 to get 2. All right? So anyway, that's kind of interesting, I think. Maybe not for you, but for me it is. Let's look at angle 3. So now, let's do this. Let's write in what angle 2 is. So let's get rid of all this mess. And let's put in a 96 right there. And now angle 3 should be very simple to do. We've already done it a couple times. What can we do? Add up what? 96 and 45. Oops, I was going to put a plus there. Plus 45. And what's that? 11, 13, 14. Is that right? 141? Yep. And so, but that's not 141 though, is it? It's when I add these up, it's 141. How do I find that third angle? Take it from 180 again. That's right. Take it. So it's 181 minus 141. What's that? 39? 39 degrees. So angle 3 is equal to 39 degrees. I'll just put a little 9 right there and a degree symbol. There we go. We found all 3 of those yellow angles. What's that? It's not hard. You're right. It doesn't seem hard because it's not. Okay? Especially if you know 2 angles of a triangle, how do you always find that third angle? Just add them up and then take them away from 180. Exactly right. Okay? And you're absolutely right. Now, if I only know 1 angle, could I find the other 2? No. Okay? But if you know 2 of them, you can always find the third one because you know they always. It doesn't matter what the shape of the triangle is. Look, this looks like an acute triangle right here, doesn't it? This looks like an obtuse triangle. Does it matter what kind of triangle you have? No, all the angles always add up to 180 no matter what kind of triangle you have. We good? All right. Now, let's talk about this. Remember I said that 96 is equal to this angle plus this angle right here? That's what we're going to talk about right now. All right? So let me draw a triangle, a certain type of triangle, I guess. But it's going to be a little bit more than just a triangle. I'm going to take that third side and I'm going to extend it out a little bit, okay? So the third side's not going to stop right here. That third side's going to go extend out. Everybody with me? So let's put some numbers in here. Let's call that angle 1. Let's call that 3. And let's call that 2. Thank you. Thank you. And we're going to call this one angle 4. Now we're going to name these angles a little bit, okay? I'm going to use this verbiage, okay, the way that I word it, okay? I'm going to use these words quite a bit. So I want you to understand what these are. Now look at this angle 4. Is that angle 4 inside the triangle? No, where is it? It's outside the triangle. But we're going to call it, remember we did that alternate stuff, alternate interior, and all that? So instead of saying outside, what do we use in geometry? We say it's the, now it's not alternate, it's the other one. Alternate, if it's outside, it's not interior, it's what? It's exterior. Good, okay. Remember that? Alternate interior, alternate exterior. So if the 4 is outside the triangle, we call this angle a what? An exterior angle because it's outside of the triangle. So what do you think we're going to call the angles that are inside the triangle? The interior angles, okay? But I want to look at 2 specific angles here, okay? I want to look at angle 2 and angle 3. Now they're both interior. I hesitate to even say this story because I do it every single time I teach this, but I'm going to tell you anyway, okay? When I was a little kid, we'd watch TV, right? This is the old days. I remember only having a black and white TV. We didn't even have color TV for a while, all right, until I was a little bit older. But you know what we would have to do if we wanted to change the channel? We're sitting on the couch, right? And we wanted to change the channel. What do we do? Do we grab the remote and go boop, boop, boop? What do you think we'd have to do? Yeah, you'd have to actually stand up off the couch. You'd have to walk over, heaven forbid, right? You got to walk over to the TV, and then it had these dials on the TV, and you had to go click, 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 click to whatever channel you wanted, right? Then you go back and you sit down again. So there wasn't too much flipping because you always had to get up and go over to it. But then, thank goodness, I'm happy about this, that they came out with what? So you didn't have to get up off the couch. A remote, okay? A remote because you're not right next to the TV. You're kind of far away from the TV. Agreed? Right? Now, some people might watch TV this close. I don't know. But the remote allows you to be far away from the television. Would you agree? So remote means what? Like if I said, oh, you know, Bobby and Susie, they live out in a remote part of the country. What does that mean? It means away from everything, right? Far away. Would you agree? So when I say remote, that kind of means far away. So with all that said, look at these 2 right here. Look at 2 and 3 compared to the exterior angle. Are they close to angle 4? No, this would be close to it, wouldn't it? It'd be right next to it. But these are not just interior angles, but what do you think, what word am I going to use that I told that whole story about? Remote, right. We call these remote interior angles. All right, so this is a remote interior angle, and so is this. The reason I'm telling you that is because of this theorem, okay? The theorem uses these words, all right? And I need you to know what they mean and what's going on here, okay? So here's what the theorem says. I'll write this in white. They call it, they have a name for it. Not all these theorems have like special names, but they call this, they do have a special name for this one. They call this the exterior angle theorem. I'll just shorten theorem to THM. Is that all right? So it says the measure of the exterior angle, I'm going to kind of shorten this a little bit. So the exterior angle is equal to the sum. Now let's talk about that word. What does that mean if I have the sum of two numbers? What am I doing to those two numbers? I'm adding them up. Exactly right. So sum means you add, okay? So the exterior angle is equal to the sum of the remote interior angles. Does that make sense to you if I read that off to you? So the exterior angle, if you have a triangle and you extend one of the sides, you get an exterior angle, right? So if you have an exterior angle, it's equal to the sum of the remote interior angles. So that means what? Which angle in this picture right here is the exterior angle? Angle what? 4, okay? So watch. So angle 4 will equal the sum. What does that mean? We're going to add the two remote interior angles. Which ones are my remote interior angles? Yep, I'll put 2 and 3 if that's all right. Angle 2 plus angle 3. So that's basically what this theorem says. Everybody see it? Now remember, this is angle 4, angle 2, angle 3. This doesn't mean the number 2 plus 3, because what's 2 plus 3? It's 5, okay? I am not teaching you that 2 plus 3 equals 4, okay? This is angle 4, this is angle 2, this is angle 3, all right? Do you agree that we've already seen that up here? Look at this. Like if I, see this triangle right here? Let's get rid of this. See how that's an exterior angle to this triangle? I took that side and I extended it. So this right here, this 96, is an exterior angle. How did I find the exterior angle? I found the sum of the what? The remote interior angles. Which ones are the remote interior angles in this triangle? The 36 and the 60, that's right. Not the 45, that 45 done. That was from something else, okay? So the 96 should equal what? The sum of the remote interior angles. These two are the ones that are not next to it, right? Because if I was right next to the TV, would I need a remote? Well, maybe today's TVs I would, because there's no way to change the channel on today's TVs. But back then, when you had a dial, you'd have to go click, 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 right? So if you're right next to it, you wouldn't need a remote. The ones that are further away from it, those are remote. You got it? They're further away. So if you add the two angles that are further away from that exterior angle, they add up to be that exterior angle. That works every single time. What do you think of that? Let's do an example, and let's see if we can, if that'll help us out. Let's change this back to white. All right, so we're going to draw a triangle with an extended side, so we have an exterior angle. Now, if you just had a triangle, like if I had a triangle like that, do you have any exterior angles? No, you don't, okay? But if I do this, if I extend that side, now you do have an exterior angle, don't you? All right, so that works in this situation. So let's put some, what color haven't we used? Have we used that purple? Purple doesn't show up very well up here, though. Yeah, let's do the red. Is that red? Yeah, this one's red. That one's pretty red. Okay, so let's do, let's say this is 64 degrees. Let's say this is, now, we're getting a little tricky here, but we've done this before. We learned some algebra, so we're going to put it to use. And this is 13x minus 5 degrees. Okay? And let's label this triangle. Make that x, make that w, make this y, and we'll just put a point out here and we'll call it z. All right? So what we're going to try to find, we want to find 3 different things. So the first thing we want to find is angle x. I'm sorry, not angle x. We're going to find what x is actually equal to. This is little x. So when I'm talking about x, I'm talking about that right there. So that's the first thing we want to find is what x is equal to, okay? Then we want to find angle w. And then we want to find, number 3, we want to find angle xyz. Angle xyz. All right? Let's solve for x first. Now, do we have a situation like what we just finished talking about? First of all, do I have an exterior angle? And what is it? Yeah. Well, we kind of, yeah, you're right. We don't exactly know what it is, but what did they tell us it is with an x in it? 13x minus 5, okay? So we kind of know what it is, not exactly, okay? So it's 13x minus 5. Do I know my 2 remote interior angles? No? Yeah, these 2 are the remote. This one right here is the one that's right next to it. See how it's right next to it? This one, okay, so this is not a remote interior angle. This is a close interior angle, okay? We'll call it that. What are these, though? These are what? Remote interior angles. This one is further away. This one is further away. So these 2 are the remote interior angles. So what we can do is set up a little algebra equation. All right? That's why we learn algebra, so we can actually use it to do certain things. All right? So let's set up our little algebra equation. First of all, let's write down what the exterior angle is. What's the exterior angle? Yep, 13x minus 5. Now, what should that equal? It should equal the what? The sum of the 2 remote interior angles. Which ones are the remote interior angles? This one and this one, w and x. So what am I going to write down for w? 5x plus 3. What am I going to write down for angle x? 64. And now I should be able to solve for x. So our geometry is pretty much done at this point. This is just algebra, so we got to solve for algebra. All right? Let's do this. Let's add some like terms first. Equals 5x plus what? What's that going to be? 67. Now what can we do? We want to get the x's on the same side, correct? So what am I going to move? The 5x. Yeah, I would move the 5x over. How do I move the 5x over? It's a plus 5x, so I subtract a 5x. We've done that lots and lots of times this year, haven't we? Right? We took a couple weeks, right, where we just did algebra, and this is a huge chunk of what we learned. So we subtract a 5x, we subtract a 5x. I could bring everything down, but what's the next thing I'm going to do? I'm going to get rid of that minus 5. How do I get rid of a minus 5? I add a 5, and I add a 5 to this. So let's do it all in one step. That's kind of nice. That cancels. That cancels. 13 minus 5. What's 13 minus 5? 8. So it's 8x equals 67 plus 5. That's 72. One more step. What's our step? Divide by 8. Right. Divide by 8 is coming back to you, isn't it? So what's x equal to? 72 divided by 8. 8 times what is 72? 9. 9. You got to know your multiplication tables. It's a lost art. Okay? Kids aren't learning their multiplication tables anymore. You got to know your multiplication tables. All right, so x is 9. So that's the first part of this. Yeah. So let's find this. It looks like an L, but it's an angle. Angle W. So I want to find this right here. Well, now it's actually pretty easy once I found x, isn't it? Do you agree? Yeah, it's pretty easy since I found x. So how do I find angle W? So angle W is equal to what? 5 times 5 times x, but I just found x. So what is it? 5 times 9. Okay? Everybody see that? X is 9. I just found it. And so, right, this x is the same thing as this x. So I just found x is 9, so I put it in for this. I'm not done, though. It's 5x what? Plus 3. 5 times 9, 45, plus 3 is what? 48. Now, it is an angle. So do I just write 48? No, I put 48 what? Degrees. Right here, do I put 9 degrees? No, I just solved for a variable. I didn't solve for an angle right here. None of these angles is 9 degrees, all right? It's just what x is equal to. So don't put an angle, or don't put a degree symbol when it's not an angle, all right? And make sure you put a degree symbol when it is an angle. All right, let's do this one. X, Y, Z, where's that? There's x, there's y, there's z. So that's x, y, z, the exterior angle. So basically, I do the same thing as I did for this, except I do it to this one, right? So let's do it. 13 times what? 9, right? Because that's my x. And then minus 5. 13 times 9. I should know that in my head. 117, is that right? 130. Yeah, if this was 10, that'd be 130. Take away 13, and that would be 117. Yes. Somebody check me. I think that's right. That's not your regular multiplication table thing, but I'm pretty sure that's right. 117? Okay, good. All right, so it's 117 what? Minus 5. What's 117 minus 5? That's easy. 7 minus 5 is 2, so it's 112. So this angle right here, XYZ, is 112. Make sure you put the degree symbol there. And there you go. That's it. Yeah, it doesn't look like I gave you too much time to do your homework. Sorry about that. But at least you know what you're doing now, right? This is like a perfect quiz or test question, all right? I mean, this is definitely something I want you guys to know how to do. So make sure you study it. I'll make sure I put it up on YouTube. I forgot I didn't do yesterday's, but I'll put it up today as well. So your homework, it's already on your lesson plan, but it's the 1 through 16. So it's section 4.1. It's pages. Did I split that up into A and B when I did it? Okay. Let's see. Let me get that lesson plan. Yeah, we'll call it A because I will give you some more. So we'll call it section 4.1A. And then it's 1 to 16. So on the lesson plan on Friday, I have you doing some extra ones, like from, 21 to 29. I'm not going to have you do that for this homework. I'm just going to have you do up to 16. All right, that's not too bad, is it? It's not too much to ask. Let's do tomorrow. I mean Friday, or whatever it is. What's today? Today's Friday. It's due Monday. This will be on YouTube. Yeah, next period, I promise. It's the first thing I'm going to do is load yesterday's and today's up on YouTube. Okay? Any questions? We good? All right.